We can also use moles to help us balance equations. Let's say we have a reaction between nitrogen and oxygen gases. There are many products that just contain nitrogen and oxygen, but in different amounts. What about nitric oxide, NO, which is very reactive, or nitrogen dioxide, NO2, a brown gas? Nitrous oxide, N2O, is laughing gas, or even dinitrogen pentoxide, N2O5, which is extremely dangerous. In reality, we would get a mixture of products and the reaction would not go to completion. But let us suppose we could make just one of these. Wouldn't it be good to know which one you made? If we work out how many moles of nitrogen and oxygen reacted, we can use the ratio to find out. If the ratio is 1 to 1, we have NO, 1 to 2, and we have NO2, and so on. We can do this knowing the weights of the reactants, or, with gases, the volumes. Remember, 1 mole of gas occupies 24 decimeters cubed at room temperature and pressure. So if we have 0.7 moles of nitrogen and 0.35 moles of oxygen, the ratio is 2 to 1. What have we made? Yes, we have made laughing gas. You can now go on to do chemical tests for laughing gas and test your assumption that all the gas reacts. Now you have a go, this time using masses. Pause the video whilst you work it out. You should have found that 28 grams is 1 mole of nitrogen and that 32 grams is 1 mole of oxygen. The ratio of moles is 1 to 1, so the product is NO. In this video, we have learnt how to use mole ratios in formulae and equations to see how much you have of each element or compound. We have met the notation AR is relative atomic mass and MR is molecular mass. We have calculated masses from moles and moles from masses. We have seen how we can combine ratios and relative masses to balance equations, and we have practiced using elements that combine in more than one way.